Watch leftover animal bones transform into elegant jacket buttons. Operators feed each bone across a thin circular saw, shaving 5 mm thick slabs. Perfect thickness for sturdy buttons. A hand-fed fly press stamps neat circles from every slab, spitting out dozens of bone coins with a satisfying clack. Coins slide under twin sandstone wheels that level both faces, keeping each disc a uniform 3 mm thick. Discs tumble inside a spinning wooden barrel full of fine gravel. After 10 minutes, the edges emerge, silky smooth and fingertip safe. A simple bench drill pierces 2 or 4 neat holes through each disc. A wooden jig keeps fingers clear and spacing perfect. Buttons spin on a leather wheel while a worker brushes water and pumice paste across the surface, raising a gentle satin shine. 4 darker shades. Buttons soak in natural dye, walnut husk or tea, then dry on mesh racks, locking color deep into the grain. A beeswax-charged cotton wheel buffs every button to mirror brightness. Inspectors tap, weigh, and bag them by the hundred for garment makers worldwide. From butchers' leftovers to fashion finish.
Ever seen animal bones turn into drinking water pipes? Give me 1 minute and I'll show you how. One smart factory said, don't dump bones, use them. Let's follow the simple trip from bone to pipe. Trucks bring big cow and goat leg bones to the factory. Workers wash and weigh them. Only clean, solid bones stay. Water jets blast off all meat. The bones dry in a hot drum until crisp. Crushers snap them into chips. Fast grinders spin the chips into smooth bone powder, softer than flour. The powder is full of calcium. Mix 1 scoop of bone powder with 9 scoops of melted plastic. The mix looks like cookie dough, but acts like super glue. The hot blend pushes through 2 long screws and out a steel mold as a glowing tube. Cold sprays freeze the shape. Robots slice perfect 6-meter pieces and print bone pipe on each. Some pipes go to the lab. Machines pump water until they burst. Normal plastic splits early. Bone pipes bend first, so crews see trouble before flood. These pipes are stronger, lighter, and faster to install. Crews need fewer cranes, save fuel, and cut costs. The planet wins too. After 50 years, old pipes are shredded and heated. The plastic turns into fuel. The bone powder is cleaned and used again in fresh pipes. Bones to pipes. Ways to wonder. Like and subscribe for more smart recycling stories.
Ever wondered where your old copper pipes? Mountains of used copper arrive at the recycling yard. Everything from snap plumbing tubes to tangled electrical wire. Workers and magnets pull out steel screws and plastic bits because pure copper brings the highest price, while heavy copper granules drop into waiting bins, 99% clean without a single chemical added. Inside a rotary furnace blazing above 1,000 degrees Celsius, the granules swirl like liquid fire. Oxygen lances burn off the last traces of oil and paint. Within minutes, the metal becomes a glowing, lava-smooth pool. Operators tilt the furnace. Molten copper slides into graphite molds and cools into 200-kilogram pigs. Ingots re-enter a reheat oven, then squeezed through giant rolling mills, thinning from brick-thick slabs to coin-thin sheets. Some sheets feed a drawing machine that stretches them into hair-thin wire, ready for tomorrow's smartphones and EVs. Copper is infinitely recyclable. Almost 80% of all copper ever mined is still in use today. So the next time you recycle a copper scrap, remember, you're not throwing metal away. Huge bins of mixed-grade steel scrap roll in. A powerful magnet lifts the metal and drops it onto a roaring conveyor. Inside the shredder, spinning hammers break the pieces small, while air jets blow away rust and dust. Clean chips travel up to a 1,800 degrees Celsius induction furnace. Melt together. 2 dies slam shut with 500 tons of force, flaring one end into the familiar mushroom head that locks against the tractor hitch. Excess flash is trimmed off by a ring cutter in the same stroke. No wasted motion. Onboard lasers measure every cut. Bad readings stop the line instantly. Pins ride through a controlled atmosphere furnace at 880 degrees Celsius, then quench in oil for rock-hard strength. After tempering, they tumble in a zinc bath for corrosion resistance, emerging with a bright silver coat that laughs at rain and mud. A robotic carousel gauges length, hardness, and pull-out force. Anything under spec is binned for recycling back to the melt shop. Approved pins snap into blister trays, slide down a chute, and drop straight into printed boxes, ready for farms worldwide. A high-speed press punches hundreds of perfectly shaped laminations every minute. These thin steel discs will stack into the stator and rotor cores that power the fan. Precision here means a quiet, energy-efficient motor. Robotic arms wind enamel-coated copper wire around each stator slot with millimeter accuracy. Automatic varnish dipping then locks the windings in place, improving insulation and lifespan. Aluminum end rings are die-cast onto the rotor stack, creating a squirrel cage rotor. The rotor is spun on a dynamic balancer. Tiny metal chips are shaved off until vibration disappears, ensuring ensuring whisper-smooth operation. Fan blades start as flat aluminum strips. Hydraulic presses curve, taper, and punch mounting holes in one motion. A quick pass through a deburring drum removes sharp edges. Both blades and motor housings enter an electrostatic booth where dry powder paint clings like magic. Technicians fit the rotor into the stator, add silent running ball bearings, and detach the decorative housing. Balance blades are bolted on, followed by the down rod and canopy. Every bolt is torque checked for safety. Each completed fan spins on a test rig for 30 minutes. Sensors verify speed, current draw, and noise level. Only units that pass 100% of checks receive the factory seal. Watch scrap aluminum cans turn into a gleaming tea kettle. Workers dump dented pots, window frames, and drink cans onto a steel table, slide into a 750 degrees Celsius rotary furnace. Flames roar as the aluminum liquefies into a glowing silver pool. An operator schemes gray dross from the surface, then ladles a tiny dose of magnesium to boost strength. Molten aluminum pours into tall, two-piece molds shaped like kettle bodies and lids. Steam rises as the metal cools and solidifies. Robotic arms pop the rough castings free. A spinning blade trims excess flash for a smooth outline. Each body blank mounts on a lathe. Rollers press against the red-hot shell, thinning and smoothing it into the final graceful curve. Drills cut a perfect pour hole. Another head mills the lid's hinge slot, keeping tight tolerances. A spot welder zaps stainless brackets onto the body. Sparks fly, but the joint cools strong. Buffing wheels loaded with rouge compound spin fast, giving the kettle a bright, reflective shine. The kettle is filled with pressurized water, no drips allowed, ready for the stovetop.